Hello and welcome. This is the video for Skill 5B, page 2. So you should already have the first page of Skill 5B completed if you are watching this video. So in our last video, we worked on the skill of adding and subtracting fractions with unlike denominators. We learned that when I am putting together fractions that have different denominators, I run into the problem of not knowing what that answer really means. I can't just give it a name. So we used the strategy of rewriting them as fractions with like denominators. And then we have this example that we did up here. Let me get my highlighter. There we go. We had this example here in our Draw It where we went through and showed how we could cut them up into the same sized pieces so that when we put them together, we can figure out what our answer really means. And then after we explored that, we used the LCM strategy to figure out just a mathematical way to do that work without having to draw it out. The good news is that I don't know why that yellow was there. The good news is that when you are subtracting fractions, we can basically do the exact same thing. Let me show you what I mean. There we go. So when I am working with fractions, there we go. When I am working with fractions and I want to subtract them, I can look at what's really happening. So like for example, here I have 1/2 minus 1/5. So I'm going to color in 1/2. I took my whole number and I cut it into two pieces, and I'm going to color in one of them. There's my 1/2. And then I want to subtract from that 1/5. So I took my whole number here and I cut it up into 5 pieces, and I'm just going to take one of those 5 pieces. So there's my 1/2 minus 1/5. Now, the good news is I can use a similar strategy and I can take a look at what that means. So if I started with my 1/2, I'm going to color it in, and then I want to take away 1/5. Here's my piece that's worth 1/5. I'm going to just kind of put it on top of my 1/2, and then I'm going to cross it out. There we go. So what's left right here, that would be my answer. So that's how much is left over when I have 1/2 and I take away 1/5. The problem is I don't know what to call that piece. I don't know what that piece is worth. The pieces I'm working with have all been different sizes, so I don't really know what it means. I mean, when I look at it, it looks like it's less than 1/5. So, you could start guessing. Maybe it's a 1/6, maybe it's an 1/8. I don't really know. But looking at it, I can see it's smaller than 1/5, but I don't know what to call it. I can't really give it a value. Let's look over here at another example. This is using our pattern blocks, which is handy because some of the pieces, when we just look at them, we can know what they mean. So here I have this example, 1/2 minus 1/6. And so I'm going to start with my 1/2, and I'm going to use my typical strategy of coloring it to look like that red trapezoid piece that's worth 1/2 of a yellow. I want to do 1/2 minus 1/6. And 1/6 is just that green triangle, because 6 of those would make up a yellow. So if I wanted to do 1/2 minus 1/6, I could draw my 1/2. Here it is. And then I'm going to put my 1/6 on top so I can subtract it away. And what I'm really doing there is I am getting rid of it. Take it away. Now what's left, if I think about my pattern block pieces, you might be thinking to yourself, hey, I know what that's worth. You might be thinking, I've seen pattern blocks that are that shape, and I know that they're worth 2/3. So if I use my pattern blocks, I can make some guesses on what I think it's worth based on what the pattern block pieces look like. And that's really handy for some fractions. But it wouldn't have worked with my original question of 1/2 minus 1/5 because there are no pattern blocks that are worth 1/5. So this helps me see that when I start with a fraction with one denominator, and if I subtract a fraction with a different denominator, my denominator is going to be different. The size of my pieces is going to change. So the problem is, when I am doing fraction addition or fraction subtraction, the pieces are all different sizes, so we don't know how to subtract them from each other. We can use strategies like pattern blocks and comparing, but we really don't know how to easily calculate it the way it is. The solution? We can just rewrite them with like denominators to make the pieces the same size. In effect, we can do the same thing that we're doing when we add fractions with different denominators. So let's try it out. Here is our solve it, and we're going to do the same thing we did in the first video, except for this time we are subtracting. The big idea is, anytime I want to add fractions or subtract fractions, you must find like denominators. I can't just subtract one denominator from the other. I need to cut my pieces up to be the same size. So looking over here, we're going to work with this question here. We have 7/8 minus 2/3. And our strategy whenever we're trying to find common denominators is to use the LCM, or least common multiple. So that brings us to step 1. Use the least common multiple to rewrite the fractions using common denominators. And if you remember, another word for common denominators is like denominators. They mean the exact same thing. So since I'm working with eighths and thirds, I'm going to find the LCM for 8 and 3. So I can list some 8s, 8, 16, 24, 32. And for 3s, I've got 3, 6, 9, 12, 15, 18. I haven't found one yet, but there's got to be one. 21, 24. Well, there it is. I guess we ended up having to multiply 8 times 3. So coming up here, I want to turn my fractions into 24ths. I know to do that, I have to multiply my denominator of 8 times 3 to get to 24. So 7 times 3 will give me 21. And over here, I've got my 2/3, and I want to rewrite that as 24ths. To get from 3 to 24, I had to multiply by 8. So I'm going to multiply my numerator times 8. 2 times 8 is 16. Now that I have these new fractions, I'm going to rewrite my subtraction problem with these common denominators. I have 21 24ths minus 16 24ths. All right, I'm going to use the count up strategy. 16, 17, 18, 19, 20, 21. That's 5 pieces. And then I'm working with 24ths. So that's step 2. Once they have common denominators, the subtracting is pretty easy. Step 3 asks me, if your answer is an improper fraction, rewrite it as a mixed number. The reason I left that there for subtraction will become clear to you, hopefully, in the next lesson. When I'm subtracting, I don't usually end up with an improper fraction, but it's always good to check. Sometimes that can just help us spot errors, but also it just helps you not forget to do that. All right, there's my answer, 5 24ths. On to the try-its. Remember, you could choose to do it on your own and then check your work, or you could choose to work with me. All right, so we're going to start with 3/5 minus 1/4. Step 1 told me to find the LCM and then rewrite it using that common denominator. Looking at 5 and 4, I know for sure I could use 20, since 5 times 4 is 20, but I'll do a quick list just to see if there's any easier options. There's my 20. I don't see anything easier. 20 it is. Now that I've figured out my denominator, I can rewrite my fractions using my denominator of 20. 4 times 5 will give me, oops, I wrote that backwards. 4 times 5 will give me 20. So I'm going to multiply my numerator times 5. I can rewrite 1/4 as 5/20. If I'm trying to go from 5 to 20, I have to multiply by 4. So I'll do the same thing to my numerator. 3 times 4 is 12. Now I can rewrite my problem. I'm really trying to solve 12/20 minus 5/20. All right, 12 minus 5 is 7/20. My answer is 7/20. Let's try it here for the next one. I have 1/2 minus 3/10. I'm going to find my least common multiple so I can rewrite them as equivalent, or I can rewrite them as fractions with like denominators. I know for sure I could use 20 because I could multiply 2 times 10 to get to 20, and I could multiply 10 times 2 to get to 20. But I want to see if there's an easier one. So I'm going to list out my multiples. Aha, there is an easier one. I can multiply 2 times 5 to get 10. That is their shared multiple. That's the lowest. So I'm going to rewrite my fractions. My 3/10 doesn't need to be rewritten. It's already written as tenths. It's just the 1/2 I need to rewrite as tenths. 2 times 5 is 10. So I'll multiply my numerator times, multiply my numerator times 5 and get 5. So my new